So in this video we will see how to design our walls for Flexure. So which means today's topic will be design of walls for Flexure. So first you need to understand wall bending. So that is behavior of wall in case of bending. So in case of bending you have two types. So one is M11 bending and M22 bending. So M11 bending is also called as horizontal bending, whereas M22 bending is called as vertical bending. So first you need to understand these two terminologies, that is M11 and M22. So if you open your ETABS model, I am using the same model which I have completed the shear design. If you see here, if you see the local axis for walls, so if you see the local axis, so red is local axis 1 and green is local axis 2. So blue is local axis 3. So 1 and local axis 1 and 2 are along the plane of wall, whereas local axis 3 will be out of plane. Okay, so this is the local axis for walls. See here. So if you take 3D elevation of the wall, you have the lateral pressure like this. It may be lateral load due to soil or uplift, and this is your wall. Okay, so this wall may bend in two directions. So first M11, which is horizontal bending. So which means your wall will bend like this. This is horizontal bending. Similarly M22 vertical bending. So this will take place like this. if you have a wall like this, so M11 bending will be M11 bending will be your horizontal bending. So this is your local axis 1, which takes place along local axis 1. Okay, so this is your M11 bending. M11 bending. So whereas M22 bending, so this is local axis 2. So M22 bending, it will take place like this. It is very difficult to visualize it here. So if you go to top of tank, so this is horizontal bending. So M11. So vertical bending, you can't see vertical bending here. So vertical bending, it will take place like this. So this is your vertical bending. So M22 bending, and this horizontal bending, this is M11 bending. Okay. So here first you need to understand M11 and M22. So you go to display force bar stress diagram, go to shell stresses bar force. So you select your long wall. So you take any elevation. So for long walls, elevation will be 1 or 2. So 1, see here. Here you have M11 and M22. So M11 is horizontal bending, M22 will be vertical bending. So if you click M22, you select combination with water pressure. You select M22 here. See here. This is the resultant M22 diagram. So which means vertical bending. So M22 is vertical bending. So similarly M11, it is for horizontal bending. So here, so component M22 is vertical bending. So component M11, it is horizontal bending. So bending moment values, both horizontal and vertical bending are given in terms of unit kilonewton meter per meter. So these are the bending moment values per meter width. So kilonewton meter per meter. Okay. See here. So your walls are designed as singly reinforced sections. So you remember these things. Walls are designed as singly reinforced sections. So no compression steel is required, which means singly reinforced means no compression steel is required. So what is the condition for singly reinforced section? Mu will be less than Mu limit. So actual moment should be less than your capacity or limiting moments. Okay. So how you calculate Mu limit? So you know the formula. Mu limit equals 0.133 FCK BD square. So this is the formula to calculate Mu limit. So this D is effective depth, depends on clear cover, diameter of bar and layer of reinforcement. Okay. So for cover, for concrete cover, we will be referring IS 456 2000. So table 16. Table 16. So table 16 will give nominal cover to meet durability requirement. So based on exposure condition, there will be a table for nominal concrete cover. Okay. So we take 50 cover for tank walls and base slab. So we will be using clear cover of 50 for both walls and base slab. So this is clear cover. So you remember, you keep it one thing in your mind. ETABS design your wall elements for in-plane moments and axial forces. ETABS will not design wall elements for out-of-plane moments. So ETABS no help in design. We rely on manual design for walls, top slab and base slab. Okay. So next we will proceed for flexure design. Flexure design or reinforcement. Reinforcement design. So as per flexural criteria, we will be using ultimate load combination. So for flexure design, we will be using ultimate limit state combinations. So ultimate load combinations. So you have three ultimate load combinations. So first is 1.5 dead load plus 1.5 water pressure. Second will be 1.5 dead load plus 1.5 earth pressure. 1.5 dead load plus 1.5 uplift. Okay. So this is combination due to water pressure. So to get the worst effect, we will be considering separate combinations. Anyway, these two comes under soil pressure only. To get the worst effects, we will be consider it as individual load combinations. So if you consider a plan of wall, assume this is 10-meter wall, 10-meter wall in plan. So from outside you have earth pressure, from outside you have earth pressure. So I will write it here. This is outside and you have earth pressure from outside. So similarly, so from inside you have water pressure. So from inside you have water pressure. So this is plan of your 10-meter wall. Same will be applicable for 8-meter wall also. Nothing change in 8-meter wall. If I demonstrate design of 10-meter long walls, then the entire procedure it will be same for 8-meter wall also. Okay. So if you take a section A, so section A, so it will look like this. So along the length of the wall, so your bottom is fixed. Your bottom is fixed. So this is section. This is section A. Again, it is outside, and this is inside. So from inside, you have water pressure, and from outside, you have earth pressure. So here you have two types of bending. One is M11 bending and M22 bending. So M22 is vertical bending, M11 is horizontal bending. So in case of horizontal bending, see here you have a connection. This wall is connected to some other wall. Again, in the right side also, this edge is connected to some other wall. So there will be a minor fixity, not fully fixed. Okay. So due to this water pressure, so your bending moment diagram will look like this. Okay. So due to water pressure, so this will be hogging and this will be sagging. Again, this will be hogging. Okay. In case of plan. So similarly for earth pressure from outside, so your wall will bend like this. Okay. So here you have hogging, sagging, hogging. So this is horizontal bending. Similarly, when you have water pressure from inside, so in case of vertical bending, So initially you have hogging at the base of the tank, then so due to water pressure, so your bending moment diagram will be hogging at the bottom, and at the mid span you will get sagging. So this is hogging and this is sagging. So this is the bending moment due to water pressure. Similarly for earth pressure, it will be reversed. So initially it will be hogging at the base, it is hogging, at the mid span it is sagging. So this is hogging and this is sagging. So we will consider one by one. See here. So this is your vertical wall, fixed at the base. You have earth pressure from outside and water pressure from inside. So we will take single case. First consider you have water pressure acting on your wall. So your bending moment diagram will be, it will be like this: hogging, sagging. Okay. So at this region, where you will provide the steel, so you will provide the steel at this location. So wherever there is a tension, you will provide the steel here. Okay. So this is hogging. So next we will provide, you will provide steel. You will provide steel at this location, at this region. Okay. So this is your M22 bending diagram, vertical bending diagram. So I will call this as steel number 1, and I will call this as steel number 2. So steel number 1 will be, this is moment due to water pressure. So it is M22, which is at base. Next 2 will be, location 2 will be, again it is vertical bending M22. It is because of water pressure, and where it is provided at mid height. Okay. So this is in case of water pressure. Similarly, if you consider soil pressure or earth pressure acting from outside, so your bending moment diagram will be just reversed. So it will be first hogging, next sagging. So where you will provide the steel, for this hogging you will put steel here in this region. For this sagging bending moment you will put steel here. So I will call this as number 3, and I will call this steel as 4. So next 3 will be, so this is M22 bending, bending. It is because of earth pressure which is at base. So similarly steel 4, so steel 4 will be M22. So this is because of earth pressure, and this will be provided at mid height. This will be provided at mid height. Okay. So you just take a screenshot of this. This is because of vertical bending. Vertical bending. So you have to provide 4 reinforcement. You have to provide 4 reinforcements. Okay. So steel, here you have the water. This side it is water phase, and this side you have earth. Earth. So steel 1 will be provided on which phase? Steel here. Steel 1 will be provided on water phase. So reinforcement phase, it will be water phase. Okay. Next, steel 2, it is provided on which side? On earth phase. So phase of reinforcement phase will be on earth phase. So next, M number 3, it is provided on earth phase. Next, steel number 4, it is provided on water phase. Water phase. You just take a screenshot of this. So this is for vertical bending. So for M22 bending, you have to provide 4 types of reinforcement. So similarly, now we will consider horizontal bending. Next, we will consider horizontal bending. So for which we will consider a plan of wall. So for which we will consider a plan of wall. See, you have water pressure from inside. So your bending moment diagram will be at the corners it is hogging, at the left and right corner you will get hogging bending moment, at the mid you will get sagging bending moment. So your bending moment diagram will look like this. So this is hogging, sagging, hogging. So where you will provide the steel? So for this hogging you will provide steel at this location. I will change the color. So for this hogging bending moment, you will provide steel at this location. So I will continue the reinforcement number. It is 5. Next, for this hogging bending moment, you will provide steel at this location. So this is 6. Reinforcement number 6. For this sagging bending moment, you will provide steel at this location. So this is 7. This is 7. So you will list like this. 5 will be, so this is for horizontal bending. Horizontal bending, which means M11 bending. So reinforcement 5, it will be M11, which will be for water pressure and which is at left support, and reinforcement 6. Reinforcement 6. So again this is M11, water pressure, right support. Next 7. So it will be M11, water pressure. It will be provided at mid span. It will be provided at mid span. So inside you have water. So this is water phase, and here you have soil. Outside you have soil. So M11, it will be provided on which phase? Water pressure left side. It will be provided on water phase. On which phase reinforcement it is provided? Water phase. Next, again this location number 6, reinforcement 6, it is provided on water phase. Similarly M7, so is reinforcement number 7, it is provided on earth. It is provided on earth. So you just record this. Okay, you assume you have soil pressure from outside. You have soil pressure from outside. So your bending moment diagram, it will look like this. At the supports left and right corners, you will get hogging, then you will get sagging, then it is hogging. So you have hogging at the midspan, sagging, again at the right, it is hogging. So then where you will provide the steel? For this hogging, you will provide steel at this location. So it is reinforcement number 8. For this sagging, you will provide steel here. So this is okay. For this hogging, you will provide reinforcement here. Okay. So 8, I will call this as 9, and I will call this as 10. Okay. So 7 completed. Next, reinforcement number 8. 8, it is again, it is horizontal bending M11. It is because of earth pressure, and it is at left support. Next, reinforcement number 9. So M11 horizontal bending, it is because of earth pressure, right support. So reinforcement number 10. So it is M11. It is because of earth pressure, and it is provided at midspan. So next, let me write the reinforcement phases. So M11, which means reinforcement number 8. This reinforcement provided on what phase? So earth phase. So I will write it as earth phase. So next, reinforcement number 9. Again it is same, earth phase. Next, reinforcement number 10. So which means this, it will be provided on water phase. Okay. For each wall, you have to inspect 10 bending moments. For each wall, you have to inspect 10 bending moments. So same will be applicable for 8-meter walls also. 8-meter walls also. Whatever I am explaining the flexure design, it is applicable for 8-meter wall also. Okay. You just have a note of it. Okay. So this is M22 bending, vertical bending. For vertical bending, you have 4 locations. For horizontal bending, you have 6. So for each wall, you have to inspect 10 bending moments. So 4 plus 6. So you have to inspect 10 bending moments. So 4 M22 moments, 6 M11 moments. Okay, you just take a screenshot of this. Later it will be used in the calculation. Okay, so next you open Excel sheet. Open Excel sheet. Okay, you need to make a tabular column like this. First, it is reinforcement mark. First column it is reinforcement mark. Second, moment. Second column it will be moment. Next, direction. Next, it will be reinforcement phase. Okay, so we'll just cut this and I'll use this. Okay, reinforcement phase. Next, design for moment. You merge these two. Okay, in design for moment you have two columns. One is moment flexure, and the next column it is AST flexure. Next column, design for crack width. We will be discussing this in the next class. Okay, design for crack width. In design for crack width, we have two columns. Moment for crack width. Next, AST for crack. Next, last will be AST minimum. Okay, so in the noteboard, so I have taken 10-meter long wall. So this is wall 1, wall W1, that is 10-meter long wall. You have to make similar table for 8-meter long wall. So just I will increase the font size. So instead of 12, 11, I will make this 12. Okay, so how many reinforcement you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so in E-tabs, see here, you go to plan, level top of tank, you go to display undeformed shape. See here. So your long walls are wall W1. So these two are wall W1. So these short walls are wall W2. Wall W2. If I explain flexure design for this wall means same will be applicable for this long wall and these two short walls. I am explaining the calculation or procedure for only single wall. Same has to be repeated for all the walls. Anyway, if you complete this long wall, same will be taken for this wall. If you complete this short wall, same result will be taken for this wall. Okay. So next reinforcement mark. So you just go to your whiteboard. So this is 10-meter wall. Whatever I explained these concept. So with regard to 10-meter wall, which is wall 1, which is wall 1. So in Excel sheet, I will first write wall 1. So W1, 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 W1. Okay. So first, so I will make split screen options. See here, first reinforcement location 1. You have location 1. Next location 2, location 3, location 4, location 5, location 6, location 7, location 8, location 9, location 10. Wall 1, location 10. I think this not required. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for each wall, you have to write 10 bending moments. Okay, next moment. So one will be if you go to whiteboard. So one will be which moment? So M22, M222. This is because of water pressure which is at base. Okay. So direction. So this is M22 bending. Direction means vertical. Similarly, location 2. 2 is M22 water pressure which is at mid height. Next direction vertical. Even I will write the reinforcement phase. So M22 water pressure base. So reinforcement will be on water phase. Reinforcement, this will be on earth phase. Next third one will be M22 earth pressure base. So vertical. So phase, earth phase. Next M22 earth pressure mid height. So reinforcement direction vertical. Reinforcement phase, it is water phase. Okay. I completed these four. Nothing, you have to feed this data to your Excel. So I completed M22 bending. M22. So M22 is nothing but your vertical bending. So direction will be vertical. So for M22 bending moments. So next we will proceed for M11, which means horizontal bending. So next location 5. So location 5 will be M11. Okay. This is because of water pressure. M11 water pressure. Left support, you will write like this, left support. So similarly location number 6, M11 water pressure, instead of left, you write left right support. Next 7, so it is M11, again water pressure, mid span. Okay, so these are M11 bending moment. So direction will be horizontal. So horizontal. Okay. Next M11 water pressure left support. So reinforcement face will be water. Next water. Next mid span, it is earth. Okay, next location reinforcement mark 8, 9, 10. So 8 will be M11 earth pressure. So simply I will copy these three. I will paste here. Instead of water pressure, I have to write earth pressure. So earth pressure EP, earth pressure EP, earth pressure. Okay, so horizontal direction. So M11 EP, which will be on earth face. Next earth face, and last it is water face. Okay, so this much you have to complete. So similar table has to be prepared for 8-meter long wall also. So water, earth, earth, water, 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 earth, 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 water. Yes, it is correct. So next, moment flexure. So moment flexure. So for this you need to refer your ETABS for load combination ultimate limit state of collapse. So you have three combinations. So 1.5 DL plus 1.5 water pressure, 1.5 DL plus 1.5 earth pressure, 1.5 DL plus 1.5 uplift. Okay, so In case of earth pressure, wherever there is earth pressure combination, for which you need to compare these two combination and write the maximum moments, because there is no place for uplift. So what you need to do, wherever there is earth pressure, you have to compare these two combinations and write the maximum moments. Same for 8-meter wall also. So next you go to ETAPS, you go to elevation. For 10-meter wall you have to take elevation along grid along 1 and 2. Okay, so this is your 10-meter wall. You go to display force bar stress diagram shell. So first it is M22. In the Excel sheet you have first M22. So first combination is water pressure. So first you select combination with water pressure. You click on apply. Okay. Again I will use split screen option. See here. See here. First you have M22 water pressure base. So your moment is M22. Here you can see the title resultant M222 diagram, which means you are referring M22. M22 water pressure. You have the combination 1.5 DL plus 1.5 water pressure. Next is base. So you go to base of the tank. You go to base of the tank. Okay. So what is the moment here? What is the moment at this location? At the base of the tank. I think it is almost base of the tank. I think we will take it as 28. So here it is 28. Next is M22 water pressure. M22 water pressure mid height. So which means at the mid height. So this is your tank. Base means you need to look at this region. Next, this is your mid height. So this is your mid height of the tank. So your tank height is 5 meter. Mid height means 2.5. Okay. So what is the moment at the mid height? I think it is almost 74, 75. So I will write it as 75. Next, see here. Next is earth pressure. So you go to display shell stresses bar force. First you select earth pressure combination. Earth pressure combination. See here. So for this, for earth pressure combination, in earth pressure you have two load combination. One is earth pressure and another one is uplift. So now the combination is 1.5 DL plus 1.5 earth pressure. Okay. So at the base it is 120. So first I will, it is earth pressure base. It is 120, 125. It is almost 125. So it is kilonewton meter per meter. So this is the moment values per meter width. Next I will change the combination. So instead of earth pressure, I will go to display. So I will select combination with uplift, close. So see, it is also same 125 almost. So next combination is uplift, uplift base. It is also showing same moment 125 kilonewton meter per meter. So this is M22, M22. So out of this you have to choose maximum value. So here both are same. So I will choose 125 here. Okay. Next at the mid height. So this is at base. Similarly at the mid height. At the mid height. So first M22 earth pressure at mid. Next M22 uplift at mid. So you go to display force bar stress diagram, shell stresses bar forces. So M22 you change the combination to earth pressure, apply. Okay. So where you need the moment M22 earth pressure at mid. So it is almost 12. So which is 12 kilonewton meter per meter. So for uplift, again you go to display force bar, shell stresses bar forces. You select combination with uplift. Click on apply. Same, it is almost 12 or 13 in this region. It is your mid height. So 12, we will take it as 12. So next you have to feed maximum value. It is 12 here. So in some cases you may get 12 here, 45 here. So you need to choose 45. Again at the base also sometimes you will get means higher value here. So 75 here. So out of this you have to choose 125 out of these two combinations. Okay. So similarly you have to fill this table. Next M11. So you go to display shell stresses bar forces. Here you select M11. First it is water pressure. Click on apply. Okay. First M11 water pressure left support. See at the left support it is almost 160, 167, 167. At the right support also same, it is 167. Next M11 water pressure at mid span. At the mid span, if you check this region, I think it is 80. Next for earth pressure. So you go to display earth pressure. So at the left it is 28. Similarly, we have to check for uplift also. So uplift. So for uplift it is showing 32. So I have to choose out of 28 and 32, maximum is 32. So here it is 32. Same value at the right support 32. At the mid span. So here it is 10. For uplift it is showing 10. For earth pressure it is showing almost 7. Okay, we will maximum is 10. So like this you need to record your moment values from ETABS. See here how you got this table, this column. So these are moment values. So which include M22 and M11. So these four are M22 values, vertical bending, and these six are M11 values. You will get it from ETABS. At load combination, ultimate ultimate load combinations. Okay. So next we will calculate AST. You have the moment. Next we will calculate the area of steel. That is AST. AST for flexure. So how we will calculate the AST for flexure? You have the formula from the basics of RCC. AST equals 0.5 FCK divided by Fy into 1 minus square root of again 1 minus 4.6 mu divided by FCK BD square into B into D. So here FCK grade of concrete it is 30 Newton per mm square and Fy grade of steel it is 500 Newton per mm square and B is unit width which means 1000 millimeter and D there will be two values for M22 M22 so depth effective depth will be 384 mm for M11 so D will be 376 mm because M22 steel will be provided at outer face. So for this it will be 450 minus 50 minus 16. I think this I have explained in shear design. In case of shear design, I calculated the effective depth values. So let me check. Yes, 376. Oh, initially our wall thickness is 350. Okay, we will calculate it. So now your wall thickness is 450 mm. So 450 minus 50 for M22 it is 16 by 2. So it is 392. So for M22 bending, so you go to Excel. So you just note it here. So for M22 bending, so your effective depth is 392. Next, for M11, for M11, so you have to take inner layer. So it will be 450 minus 50 minus 16 minus 16 by 2. It is 376. 376. Okay. You substitute all the values in this equation. You will get AST flexure. So these moments, whatever you have calculated the moments, are in kilonewton meter. You convert these values to Newton millimeter. Then you substitute in this equation. You will get AST values. So otherwise you can write a Excel formula for this. So you go to new sheet. So FCK 30, 500, sorry, grade of steel 500, width 1000, D 392, and so your first moment value is 28. Yes. So 165. So it is 165. Next, your moment is 75. So I will change the moment value 75. Where area of steel is 448. So I will write it as 450. Next, your moment value is 125. 125. It is 757. So 760 mm square. Next, your moment value is 1270. Next, M11 bending. Sorry, M11 bending, I have to change this D 376. So here I'll change 376. So first moment value is 167. 167. It is 1072. So 1072. Next same 1072. Next 80. For 80 it is 500. Next 32. 32 it is 197. We will take it as 200. 200. 200. Next for 10. 61. We will consider 60 mm square. So these are area of steel. So AST mm square per meter. So I have converted this moment values to area of steel by using equation AST equals 0.5 FCK divided by Fy into 1 minus square root of again 1 minus 4.6 mu divided by FCK BD square into B into D. By using this equation, I have converted moments to equivalent areas. So, similar calculation has to be repeated for 8-meter long walls. Next, we will see how to calculate AST minimum. We will see how to calculate AST minimum. So, for which you need to refer IS 3370, IS 3370. So let me open the code. IS 3370. I think part 2. So if you open part 2, here, yes, table 5. So here you have table for minimum percentage of reinforcement. So you are using grade of reinforcement as FE 500. So ground supported tank, I think it is 0.24%. So I will go back to my Excel sheet. It is 0.24. I will add percent, 0.24%. So 0.24% of what? See here, it is very important, for which you need to refer this clause 8.1.1. The minimum reinforcement in walls, floors and roofs in each of the two directions at right angles within each surface zone shall not be less than the percentage specified in table 5. So it is, which is 0.25% to 4, 0.24% of surface zone. What is surface zone? See here, to understand the surface zone, again you need to refer figure 1 and figure 2. See here, figure 1 and figure 2. So for this figure, surface zone for walls and suspended slabs. See here, for depth less than or equal to 500 mm, assume each reinforcement face controls D by 2 depth of concrete. Okay, so here surface zone for walls and suspended slabs. So suspended slabs means those slabs which are not resting on ground. Suspended slab means which are not resting on ground. Okay, so this is applicable for walls and suspended slabs. So in our case, depth of wall is 450 mm. So which is less than 500. So assume each reinforcement face controls D by 2 depth of concrete. So in this case, AST minimum, it is calculated as 0.24% of surface zone dimension. Zero 0.24% of surface zone dimension. So how to calculate this surface zone dimension? So 0.24% means 0.24 divided by 100 multiplied by, so it is for 1 meter width 1000. So surface zone dimensions here, whenever your wall thickness is less than or equal to 500 mm, assume each reinforcement face controls d by 2 depth of concrete. So here surface zone dimension is d by 2. So in this case 0.24 divided by 100 multiplied by 1000 multiplied by 450 divided by 2. So your AST minimum will be 0.24 divided by 100 multiplied by 1000 multiplied by 450 divided by 2. So it is 540 mm square. So 540 mm square per meter. So this is AST minimum. Clear? So this is figure 1 for surface zone for walls and suspended slabs. So I will go back to my Excel sheet. So here I will go to select all the rows and go to merge and center. So here area of steel, it is 540. Mm square. So you got AST minimum. So if you refer the clause, so figure 1 is for walls and suspended slab. So in case of ground slabs, so you need to refer figure 2. So this figure, surface zone for ground slabs. So here you have the two diagrams. One is whenever is your depth less than 300 or less than 300 mm, you need to refer this diagram. Whenever your ground slab depth is 300 to 500, you need to refer this. Whenever your diagram or depth of ground slab 500 mm or more than 500 mm, you need to refer this. Okay. So in our case, AST minimum is 540 mm square. So you repeat the entire steps for 8-meter long wall. You repeat the entire steps for 8-meter long wall. Okay. So in the next session, we will see for crack width design. So here for any wall there may be three types of reinforcement. So 1, 2, 3. So one is for AST flexure. Second is for AST crack width. Next third one is AST minimum. So final AST we will be providing maximum of 1, 2, 3. So finally we will provide maximum of 1 and 1, 2, 3. So 1 is for AST for flexure, 2 is for crack width, 3 is AST minimum. So out of these 3 I completed AST flexure calculation and AST minimum calculation. So in the next video we shall see AST crack width, how to calculate AST for crack width, which means we will see crack width design of wall for your crack width. So today's assignment is you make similar table for 8-meter wall. So instead of 10 meter you write 8 meter here. This remains same. It will changes. Your moment values will change. If your moment value changes, area of steel will also changes. This is same, 540 is same. Okay. And so your long wall is wall 1. Here short wall is wall 2. So instead of W1, you write W2 everywhere. Your location remains the same. 1, 2, 3, 10 remains the same. Instead of W1, you write it W2. So this is for your assignment. This has to be completed. Same, whatever the steps I explained for 10-meter wall, you have to repeat same for 8-meter wall. So in the next video, we will see crack width design. We will see crack width design.